Okay, so proportional reasoning with percent. So we're learning that percent means out of 100. So that's really important to know when we're solving problems. And we're learning to use proportional reasoning to solve problems that are related to percent. Okay? So this is one thing that's, I don't know if you guys all realize that these four things all mean 25%. So 25% means 25 out of 100. Okay? It means 0.25. It means 25 to 100, all of those things. Okay, and the key there is that 25% means 25 out of 100. Percent means out of 100. So how do you go from here to here? You go on your calculator and you do 25 divided by 100. And that's what gives you 0.25. And then how do we get from here to here? Well, we think of this fraction as a ratio. 25 to 100, 25 over 100 means the same thing. Okay? And then how do we get from here to here? We remember that percent means out of 100. Okay? So those are the connections, and now we're going to look at a table. So if you start off with 75%, what fraction would that be? You know it means out of 100, so it would be 75 out of 100. Okay? What's that as a decimal? Type it out on your calculator. 75 divided by 100. 0.75. As a ratio, come over and rewrite your fraction as a ratio, 75 to 100. Okay, so based on this row, try the next row. See if you can get the fraction, the decimal, and the ratio. Okay, so saw lots of people with 15 out of 100, perfect, for their fraction. And then for their decimal, 15 divided by 100 is 0.15. And for their ratio, 15 to 100, perfect. Okay, so now it's a little bit different because on the third row down, we're starting with, we're not given the percent, we're given a fraction. So if you want to go from fraction to decimal, it's just 1 divided by 2, top divided by bottom. So if you do that, you get 0.5. Once you've got a fraction, you can write the ratio because this 1 over 2 means 1 to 2. Anyone know how we could get the percentage? No? Okay. What does percent mean? Out of 100? Okay. So percent means out of 100. So we know we've got 1/2, but we want to know what that is out of 100, right? So our fraction was 1/2, but we want to know what's 1 out of 2 if it was out of 100 instead. Does everyone see that? And that's a question we know how to do from yesterday. You can do it on your whiteboard if you want, or you can do it, write it down really small in the little box they give you. So that's going to be 2x equals 100. Divide by 2, which gives you 50. So that would mean that this was 50 out of 100, which is 50%. Okay, this percent means out of 100. %. Okay, any ideas what we could do to rewrite point 2 as any of these three things? What do we know that percent means? Out of 100? Okay, so let's go again. So we've got something out of 100, that's what we're trying to find, that's our percent, equals 0.2 out of, if there's no number in the denominator, what's the number in the denominator? 1, good. So 1. So we can use our find x. X times 1 is x. 0.2 times 100 is 20. Okay. So now we know that it's 20%, but we also know it's 20 out of 100, because those are two ways of writing 20%. Okay, so we can fill in both of those columns in our chart. %, 20 out of 100, which means we can do the ratio as 20 to 100. All different ways to write 20%. This one, 13 to 100. Well, we know we can write it as 13 over 100. That's just a different way of writing the ratio. We know that 13 out of 100 means 13%, because out of 100 means percent. And then we can do 13 divided by 100 to get the decimal. 0.13, perfect. Okay, and then this one, because it's over 100, makes it a bit trickier, but it's still 125% means 125 out of 100. Then you divide to get the decimal, which is 1.25. And then to get the ratio, it's 125 to 100. Three-fifths. So we know we can fill in the 3 to 5. We can rewrite it as a ratio easily once we've got the fraction. You divide to get the decimal. 3 divided by 5, 0.6. And then we can use proportional reasoning to get the percent if we want. We could do 3/5 is what out of 100? Okay, 3/5 is some number out of 100. And then we can do our cross multiplying. So that's going to give us 5x equals 300. Which gives us 60%. 1.15. Any ideas? We know that if we want our fraction as a percentage out of 100, anyone know what you would do something divided by 100 to give you 1.15? You look up at this one, 125 over 100 was 1.25. 115 over 100 would be 1.15. And then once you've got the 115 over 100, you know that's 115%. And you can write it as a ratio. And 1 to 25, we can write as 1/25. We can divide to get the decimal. And then we can do a proportion to get the percent. 1 over 25 is what out of 100? Which gives us 25x equals 100. Or x is 4. So that must be 4%. Anyone see a connection between this column, these two columns, the decimal and the percent? The decimal and the percent. The decimal and the percent. What's the connection between the decimal and the percent? Yep. Yeah. So 75% is 0.75, 15% is 0.15, 50% is 0.5. So the easy way to get from the percent to the decimal is just to divide by 100. Or to go the other way, to go from the decimal to the percent, you do the opposite, which is multiply by 100. So if I divide by 100, I get 0.75. If I multiply 0.75 by 100, I get 75. If I divide by 100, I get 0.15. If I multiply by 100, I get 15. If I divide by 100, I get 0.5. If I multiply by 100, I get 50. So if we use that technique here, if I know the decimal, I should be multiplying by 100 to get the percent. So if I do 0.05 times 100, it gives me 5%. Then I can test it out. If I divide 5 by 100, do I get 0.05? Yes. So once I know the percent, I know the fraction is 5 out of 100, and I know the ratio is 5 to 100. So that's a good connection to know. To go to the percent to a decimal, you divide by 100, and to go from the decimal to the percent, you multiply by 100. Okay, so now we're just going to go to our problem solving. We're always going to use this graphic organizer, which is going to help us make our proportion. Once we figure out the, I don't know if this one works for you, but this is the one that I had. So we're always going to have this graphic organizer here, and once we make it, once we fill it out, that's going to tell us our proportion, and the questions are going to become really easy. So our first example says Kimmy got 42 out of 56 on her driver's test. what percent of questions did she get correct? So this is a classic percent questions. What percent did I get on my driving test? Okay? So the top on the left side is always going to represent 100%. This is the percent side, and this is the number side. Okay? So 100% represents the top. So Kimmy got 42 out of 56 questions. What are the total number of questions? 56. So 56 goes on the top of the number side. If she got all 56 right, she'd get 100%. Does everyone agree with that? But she didn't get all 56 right. She got 42 of them right. So you want to kind of figure out, where would I put 42 along here? If 56 is total, 42 is more than halfway. So it doesn't matter where you put it, as long as it's a bit more than halfway. She got 42 correct. We want to know what that is as a percent. So that's X percent. Okay? Once you've been able to make this, that makes your proportion. So when you go to make your proportion, you've got 100 over X equals 56 over 42. And then when you solve for X, that would be the percent she got. Okay, so 100% would be if she got all 56 questions right, but she only got 42 questions right. What percent is that? Okay? So this little graphic organizer at the side will help you make your proportion. Once you've got your proportion, it's yesterday's question. Okay? So you're just going to find your X and cross multiply. So you get 56X equals 4,200. Divide both sides by the number in front of the 56. Thank you. 75. And then look back at your picture. 75 represents the percent she got. So therefore, Kimmy got 75% of the questions correct. Okay, next example. In Christopher's class, 92% of all the students in the class have internet access at home. If his class has a total of 25 students, how many students have internet access? So this time we're told 92% have internet access. On my graphic organizer, on the percent side, 92 is pretty close to 100, so I'm going to put my little line here. 92% goes here. Okay, so 92 is pretty close to 100. The total number of people in his class is 25, so 100% of the people in his class is 25 people. But we want to know how many people have internet access. That's X. Okay? So that makes our proportion for us. As soon as we've got this figured out, we can make the proportion 100 over 92 equals 25 over X. And then we can cross and solve for X. So find your X and cross multiply. So 100 times X is 100X. 92 times 25 is 2,300. divide by 100, and you get 23. Then you look back here and see, what does 23 represent? 23 is the number of kids in the class that has internet access. So remember, when you write your therefore statement, answer the question they ask. How many students have internet access? So therefore, 23 students have internet. Okay, so you fill out the graphic organizer at the side. That helps you make your proportion. And then it just becomes yesterday's question. You have to make sure that you write your therefore statement. In order to graduate, all students must complete 40 hours of community service. Erica has completed 70% of her hours. How many hours has she completed so far? So they give me 70%, which is maybe here, 70%, more than halfway. But it says to graduate, you need to complete a total of 40 hours altogether. So does my 40 go at the top with the 100 or with the 70? How do I know? The top, because that's the total number of hours. So if I did 100% of my hours, I would have done 40 hours. Okay? But I want to know how many I've done if I've done 70% of them. So once I've completed my diagram, I can now make my proportion. It's going to be 100 over 70 equals 40 over X. And now I can cross multiply. So find your X, 100X equals 2800 divide by 100, and you get X is 28. So that X there is 28, which means she's done 28 hours of her community service. So therefore, Erica has done 28 hours of service. So that means 28 out of 40 hours is 70% of her hours. Okay? All right. Louise works at a jewelry store. She is paid by commission. She earns 9.5% of her sales. 9.5 out of 100, that's not very much, right? Less than 10, so way down here, she earns 9.5% of her sales. One week she sells $7,290 worth of jewelry. How much did she earn in commission? So this is her commission, the 9.5%. It would be nice if she earned $7,290, but that's just how much she sold. So that goes up at the top. And then she gets 9.5% of that. Okay? So from that diagram, you can build your proportion. 100 over 9.5 equals 7,290 over X. And you can cross multiply. So you get 100X, find your X and multiply, equals 9.5 times 7290, 69,255. Oops. 69,255. And you get x equal to, we have to round here. Oh, it's money, so that's okay. Dollars and cents, $692.55. And then again, if you forget what it is, we come over to our organizer. This side is money, right? And then make sure you answer the question, which was how much did she earn in commission? So therefore, she earned $629.55 in commission. Yep.
I think it's 692. Yeah.
It is, thank you. Good job, guys. Erase it over here too. 692.55 in commission. Everybody get any idea? So you're always going to fit your percent. If you're given percent, and if not, the total goes here, and then how close to the total are you? Right? And then once you fill this out, you can make your proportion. There are 600 students at the school. 1/3 of them, so this is an EQAO question, 1/3 of them bring their lunch to school. 40% of them buy their lunch from the CAF. 5% buy their lunch from local restaurants. The rest go home for lunch. What number of students go home for lunch? Justify your answer. All right, so let's look at these one at a time. How would I figure out what 1/3 of 600 students is? Any ideas? I want to put them into groups of 3 to figure out how many 1/3 is. Any ideas? So if I want to put them into groups of 3 equal groups. Oops, undo. Groups not undo. So this is 1/3 means I want 3 even groups. But I want to split the 600 into 3 even groups. Does that make sense? So that to do that, you divide by 3. So let's try it out. 600 divided by 3 is 200. So if I put 200 in each group, does that add up to 600? Does that make sense to everybody? Okay, so 1/3 of them bring their lunch to school. So is everybody good that 1/3 of them is 200? So 200 bring their lunch to school. Okay? So now how many are, now you know that. You know that 200 bring their lunch to school. 40% of them, now you have to read carefully because sometimes now we're down to 400, like they'll say 40% of the ones left buy their lunch from the CAF, but they don't say that. They say 40% of the total, 40% of the 600 buy their lunch from school. So in order to do this one, we have to make one of our little charts here with 100% at the top and 600 students still at the top. Okay, it's not 40% of the kids that are left, it's 40% of kids in total. Okay? And 40% is below 50, so I'm going to put 40% down here and X over here. And now I can make a proportion. Good morning. I'm on the last question. And then I think Mrs. Hussey's coming in at some point to talk to them about course selections. So I can make that proportion. You copy this down, Tanner? Okay. So we can cross multiply. 100x equals 24,000, yeah. And then divide by 24. Oh, sorry, divide by 100, my bad. And you get 240 students. So then you can come back up here. 240 students buy their lunch from the CAF. 200 bring their lunch to school, so we know that so far. So we're on our third clue, which says 5% of students buy their lunch from restaurants. Okay? And that's from 5% of the students in total. So we're going to make another one of these diagrams with 100% at the top. 5% is really low, so we're going to put it way down at the bottom of our percent side. We know we have 600 students in total, and X is going to be how many buy their lunch from local restaurants. Okay? So now we can make our proportion. 100 over 5 equals 600 over X. Find your X and find the cross product of each side. So divide by 100. So 30 students buy their lunch from local restaurants. And then finally, our last clue says what is going on? Here we go. The rest of the students go home for lunch. Okay? So we don't have to do a proportion for that. We just need to take our 600, subtract off the kids that bring their lunch, which was 200. Subtract the kids that buy their lunch from the CAF, which was 240. Subtract the kids that buy their lunch, which was 30. And that's the rest of the ones are the ones that go home. Awesome, thanks, Claire. So therefore, 130 students go home for lunch. So in a question like that, you just have to read the clues really carefully. Because sometimes it's based on the total, and then sometimes you're subtracting as you go. It depends on how they word the question. All right, awesome. Practice. Okay, come on. I just have to stop the recording.